We're going to talk about perimeter and area in a coordinate plane. Today we'll do perimeter, tomorrow we'll do area. What part of this room, looking at it, what is the perimeter? What does it look like?
What's the perimeter of the board?
I'm asking the questions here. What does the perimeter of this room look like? Anybody can answer.
106. A square.
I'm sorry, Allie, what are they? The walls are the perimeter of this room. All right? Whoops. The area of this room, what would accurately represent the area of this room? The floor, the carpet, the ceiling. That's the area. Today we're going to do perimeter, and then tomorrow we will do area. We got some words to learn. So we're going to start with the word polygon in general.
5.
No. A lot of people think a polygon is a pentagon. They're not the same thing. A pentagon has 5 sides. A polygon is a shape, and I'm going to tell you about it. You're going to write it down. A hexagon has 6 sides. A polygon is a generic term. Are we okay with it? Like last year you learned polynomial, because poly means, like, yeah. So, polygon. It is a closed figure. This is as shortened as I can make it. It is a closed figure formed by line segments, and each side intersects 2 other sides. So it's a closed figure formed by line segments. Closed figure formed by line segments. And each side intersects 2 sides. All right, so I'll draw a type of polygon. So here's what it means. It is closed. If I try to, put something in this box, it's not going to, escape. Each side intersects exactly 2 sides. So if you look at this corner, how many sides is it touching? 2. This side is touching 2 sides. Okay, that's what makes it a polygon. If I added a diagonal like this, would it be a polygon? No. It would no longer be one for many reasons. At this corner, how many sides does it touch? 3. Okay? What about a circle? Is it a polygon?
No, it don't got no sides.
It doesn't have any sides, so it's a no. Only line segments form a polygon. What about this guy?
No, it's not closed.
No, it's not closed. Wonderful. So you know what a polygon is. We're going to talk about the list of polygons, which is the chart you see in the middle. But we're going to talk about some words first. The side of a polygon, all I want you to write is that they're line segments. The sides of the polygon are line segments. The sides of the polygon are line segments. Wonderful, Nick. Wonderful. The vertex, I actually want you to write 2 things. Can anybody guess what vertex is plural?
Vertices.
That is correct. You're going to write that. Because you will never see one vertex. It's spelled like this. V-E-R-T-I-C-E-S. Vertices. Vertices. That is a word. You won't really see vertex very often because polygons have more than one vertice. Here's what you're going to know about them. They are the corners. That's what you're going to write. The vertices, they're the corners. They are the corners. How many vertices are there in a triangle? 3. And in a quadrilateral? 4. And so on and so forth. They have the same amount of vertices as they do sides. The last word we're going to talk about, we're actually going to talk about it and its opposite, is, you can ignore these, we already filled them in, convex. I already shortened it as much as possible. Convex means all line segments point outward. All line segments point outward. All line segments point outward. Do any of you wear contacts? So you've heard of convex, concave with contacts, yes? When you put your contact on your finger, you want it to be concave, because if it is convex,
it's gonna hurt.
Yeah, the edges curl up and they hurt because the sides point outward. Concave means caves in. Convex means the sides point outward. So I'll show you an example with this beautiful, look, that was perfect. Here's how I tell. I usually eyeball the center, and then I decide if any of the segments go towards the center. Do any of these segments move towards the center?
I don't think so.
They don't. So this is called convex. However, if I were to draw a star,
That's concave.
it's concave because a bunch of them come in towards the center and that would be caving in. So concave is like a star. All right. The next section, we're going to be talking about the names of polygons. They're named by the number of sides they have. So we're going to start with an easy one. It's 3 sides. Triangle. Go and fill in that blank. You are required to know up until 12 sides.
What class?
The whole year.
In this class?
In this class. It is a standard we need to learn.
That's
What?
not the
There's
college
11.
course.
There's 12.
No, I'm talking about, is there another?
The amount of sides? Yeah. They go all the way up to 96 sides. We will not learn that much. I will show you.
Okay.
Okay. All right. I'll explain why there's 96. 4. What do we call a 4-sided polygon?
Square, rectangle.
Quadrilateral.
Quadrilateral. Who said it first?
Me.
Max.
Snatch. Actually, if you want to be technically honest here, if you check the film, Snatch really said it.
I am recording.
Really was that?
It was Snatch. It was Snatch.
You know these are individual.
Yeah, and I bought those, so.
You can both have one.
It was Snatch. I'm not gonna lie, it was Snatch.
I don't care. Here we go. It is called a quadrilateral. Go ahead and fill it in. Why would you? How'd you do that? Quadrilateral. Fill that in. 4. Quad. Quadrilateral. Quadrilateral. Everyone knows 5 sides because they think that means polygon.
Pentagon.
Pentagon. Penta means 5. So 5 sides. 6 sides.
Hexagon.
Hexagon.
Hex.
7 sides.
Oh, no. What it is? Pentagon.
Close. It starts with an H actually.
Pento.
Heptagon. So a lot of you were saying septagon, and I don't know what in life is a septagon.
Decepticon.
I've heard it, not a septagon. Heptagon is the word you're looking for. Everyone knows 8 sides is, what's the most famous octagon? Stop sign.
Octopus.
You know, there's
Or the octagon in
W,
Washington, D.C.
W,
Right?
that's a pentagon.
Oh.
Octagon.
I thought you were going to say like the, is it WWE or MMA that has an octagon?
That's UFC. It's not UFC.
Sure. There's too many letters to remember, so you relax. UFC. 9. Can anybody guess 9? It is a nonagon. Good job. It's nonagon. Nonagon. Everyone should know 10 sides.
Hectagon. Tectagon.
It's decagon. Yeah,
Why
let's
don't they
see.
got one for 2? They should have
Too
like a
much.
Biogon.
So here's the question. Here's the question, bub. It has to be closed, right?
Bro, Nick, you gotta do better.
Has to be closed, and each side has to touch 2 sides.
Impossible.
So it's not. That's why.
Science is
We call this an angle, actually. It's 1.5.
I'm gonna come up with a shape like that.
All right, you do you. But it has to be segments, right? It can't be like a semicircle type thing because that would not work. All right, so now you're going to write 11. Ready?
11.
So,
Tentagon.
relax. Listen. Every team, so 11, 12, 13, 14, 15, all the way up to 19, they end in decagon because decagon means 10. So think, if you're not in Spanish, then relax.
Uno decagon.
Can you relax? If you're in Spanish, you know that every 10 has like a suffix, like 30 is trienta and so on and so forth. So the suffix is decagon. You're going to put a prefix and then decagon for each and every one of them. You're required to know 11 and 12. You're not going to guess 11 because it is hen decagon. Hen decagon. Hen decagon. 12, you might be able to guess.
Bidecagon.
No.
Ren decagon. Dos.
It's very close to dos decagon.
Ducagon. Orthogon. Dudecagon.
Delta.
It is dudecagon.
It is do
I
decagon.
said it at first.
It is do, not doo-doo, you do-do. It's do decagon.
Dudecagon. Wait, no, what is it?
You missed it. Do decagon.
Dodecagon.
Like do, do.
Do, re, mi, fa, do, la, ti, ta.
Not what I was saying, but yes. Like that. Wonderful. That's what I was saying. All right. After that, you're not required to know. So here's what you would write. Pick a number. No, I'm not doing that.
50.
If you, sure, 52 would be 52
No, why would you let him do it?
gone.
Oh.
Any number after that, you can. There is an official name for it. We are just not required to know it. So There's a number all the way up to 96 sides, and then after that, what do you think the polygon looks like?
Weird.
Every side you add, it looks more and more like what shape?
A circle.
Looks more and more like a circle. So like some fancy man back in the day named Archimedes would sit around and just do math because they didn't have TV or, wives. And so he figured out how many sides that a polygon could have, and 96. 96. After that, it is a circle. It's a circle. Okay, sure. Argue with me, Cam, who did not get a 100 on his test. Argue with me. Come see me. Catch me outside. Anyways, that's it. So we're going to classify at the bottom. I'm just kidding, Cam. You're capable of a...
I don't know you know 100 on your test. I just know it.
You could someday. Here we go. Classify each polygon by the number of sides. So first of all, I usually count the vertices because it's easier for me to see. The amount of vertices that there are the amount of sides that there are. So however you want to count it, it doesn't matter to me. It does have 1, 2, 3, 4 corners, which is a quadrilateral. Quadrilateral. I am getting there. Quadrilateral. All right, and then you want to visualize the center. Do any of the sides come in towards the center?
Yes.
Yes, so that makes concave. Correct. All right, the next one has 1, 2, 3, 4, 5, 6, which hexagon?
It's a
Convex.
convex.
Convex, because none of the sides go inward. They all point outward. All right, and then bottom left, 1, 2, 3, 4, 5. It's your favorite word. It's a pentagon. All right, and then here's the center. Do any of the sides go in towards the center?
Yes.
Yes. So concave. All right, number 2, 1, 2, 3, 4, 5, 6, 7. Heptagon, and then do any of the sides go inward? No, so convex. Good. Now we get to perimeter.
This my packet's so thick.
That's why. It's not front and back, if you notice. So normally it would be. I don't know why it's not printed that way. They're a hot mess in printing. And we're not doing it all today. So, first thing we're going to write is what is perimeter. You ready? It is the length around a shape. It is the length around a shape. Here's what you're going to write under it, and you're going to highlight this. How do we find the perimeter? Add all the sides. So you're going to write that. Add all sides. Add all the sides. Okay, so in the last section, we learned what these tick marks mean, right? What do they mean?
All the sides are equal.
Congruent in length. All right, so this first one, yes, all of these tick marks mean that they are the same length. So we got 5, 5, 5, and 5. So add them all up. 5 plus 5 plus 5 plus 5 is 20, and you do need to write centimeters. I will take off points if you do not. Why not? Why, Miss Marshall? Here's why. Nope. A lot of students will take the dual enrollment tests, and I don't know if the SAT also does this, but these tests are designed to see if you know actually what you're doing. So on the test, letter A, the option would be 20 centimeters. Letter B, the option would be 20 square centimeters, and you need to know the difference between the two. Perimeter, you answer in centimeters. You could take a centimeter stick, I don't know, and measure all the way around the perimeter of my room. Okay, square centimeters, I'm going to explain. This is for area. All right, so you do need to know the difference, which is why you're going to have to write centimeters. Okay, if you don't know the unit, you're going to write unit. So if it doesn't say feet or inches or centimeters or whatever, you just write units, and that would work just fine. All right, we got our triangle. We've got 2 dashes, 1 dash, and 1 dash. So here's why these 2 dashes are here. You match up the amount of dashes to figure out which segments are congruent. So what is the measure of this bottom segment going to be? 1 foot because it's got 1 tick mark and 1 tick mark. That's all it means.
How that side 1/2, another one 1 foot.
It's 1 foot, 1 foot, and 1.5. All right, so now we want to find the perimeter. 1 plus 1 plus 1.5.
3.5.
3.5 feet.
Ooh, they got some hardwood down here.
Square feet.
What?
Feet.
Feet.
It's not here.
It's not squared. So I will explain why we write the word squared towards the end.
Area is the inside.
Correct. And I'll explain it. All right, so we're going to skip the one that says honors above it, like C. We're going to skip that one. You are going to do this one. You probably want to outline it. No, you're not turning. Why are we turning the page?
It's not on there.
Well, you want to probably draw it. It's on the right side. It's under letter D. Nope, not all of it. Just letter C. So we're going to find the perimeter by adding all the sides. Go ahead and re-outline it since it didn't print very well. And that is why I print your notes for you. I try. All right, so to find the perimeter, we would add all the side lengths, yes?
Yeah.
Are we ready to start doing that? Yes, no, maybe so. We would take 13 plus 6 plus 8, 9,
I mean 7.
plus 7. Is that all of the lengths? No, we need to find the other two. So here's the trick to figuring out this horizontal length. You don't have to highlight, just look at the horizontal lines, right? The full length across is how far? 13. All right, we know from here to here is 8 meters, right? The full length is 13. From here to here is 8. So what do I do to find this one? Subtract. 13 minus 8 is 5, which I think is what you said. Yes.
Why wouldn't it be 6?
Why would it be 6?
Because it looks exactly the same. Maybe like an inch shorter, but like it looks
1 meter shorter. I would never use your eyes. I would use the math.
Okay.
Because these are, sometimes I draw them. And I'm not drawing to scale. I didn't take out a meter stick and draw this. So, and some of them will say not drawn to scale. But this one I would say is not. Because meters, 1 meter is like a yard. So this is like, that makes sense. So I wouldn't use your eyes.
Alright. I just thought 6 and 5 were congruent.
Unless it said it, what would it say if they were congruent?
The little line.
A little line. But it does not, so they're not. Yeah. All right, we're going to do the same thing the other direction, right? We're going to figure out the length of this line. All right. So we know from here to here is how much?
13.
From here to here
Oh,
is 6. And from here to here is
7 and 8.
7, not 8. 8 goes horizontal.
13.
So the full length is 13.
So why didn't it have the line?
Because sometimes it doesn't write the line. It doesn't have to have it.
Because I would have thought that one was
You have enough information without letting you know that it's congruent.
Okay.
We found it out anyways, didn't we?
Yes, ma'am.
Mm-hmm. All right, so now we have 7 plus, we're going to do this 5 meter at the bottom, plus that 13 over here. So we just add now. I think it makes 52.
Meters.
Yep, 52 meters. Nope. Still meters. So when you say squared, listen. When you say squared, you're saying you can fit 52 squares inside here. That's why it's squared meters. But I don't want that. I want to know if I took out a ruler, a measuring tape, or whatever, how long around it is. So no squares.
That makes you clarified.
Wonderful. Wonderful. Now you can turn to the next page. Skipping that one, that's honors. So, if you notice, the graph did not print, and that's an issue. So here's what you're going to do. You're actually, so you can figure out which picture goes to what problem, we're going to label this as A, and then on our graph, also label it as A. Oh, wait a second. So on your notes paper, label it A, and then your graph A, so that you know which one went with what. So you're calling this A and this A.
Oh,
What?
okay.
It's already drawn for you. What do you mean draw a graph?
I'm sorry.
That's why you got this paper. So you wrote A on this one too?
What was with the voltage?
Yes.
You were. All right, so here we go. First of all, what shape am I going to end up drawing? What do we think?
Where?
Oh no, 3 sides triangle.
It's triangle, and I know that for 2 reasons. How do I know?
It's 3 numbers, 3 points.
I mean, it literally tells me that I'm going to do a triangle. And the other reason is there's 3, what do we call these?
Vertices.
Vertices. They are coordinates. 3 vertices. Okay, so it is going to be a triangle. So something I want you to write, not this. This is just letting you know this says triangle ABC. You're going to write on your notes something very important. Whenever we find the perimeter, we count the side lengths, right? How do we find the side length of a horizontal line? Don't overthink it. Think back to your
Count
test.
the squares.
You count the squares. What about a vertical line?
Count the squares.
Count the squares. But a diagonal line, you cannot. What do you have to do?
Midpoint.
You have to y minus.
Rise or run.
Midpoint.
You want to find the length of it, yes?
Yes.
So you want to find out how far apart they are, yes?
Yes.
That's called the distance formula. All right, let's write it down. Distance formula. When did I ever said slope?
I thought
Never. Probably, we'll do it once in the year. All right, so you're going to write horizontal and vertical lines. You're going to count. Horizontal and vertical lines, you're going to count. You're writing it down. I'm not saying it for my health. I'm saying it for yours. Horizontal lines and vertical lines, you count. Horizontal and vertical lines, you count. Diagonal lines, you use the distance formula. So, vertical and horizontal, you count. Diagonal, you absolutely cannot count. You have to use the distance formula. So, diagonal distance formula. I would highlight that so you can find it later on. Just put a box around it so you can find it. Yeah. Oops, sorry. Didn't mean to take it away. So, you have an X and Y axis, yes? So I'll draw mine. All right, so let's go ahead and write or plot our points. We got -2, 3. From the origin, will I go left or right? To the left 2 and then up or down? This is left and then up. So to left 2 and then up 1, 2, 3. You need to label the vertices. Why, Ms. Marshall? It's for your own benefit. At the end, we're going to have one diagonal line. You're going to need to use the distance formula. So you need to use the correct coordinates. Therefore, you need to know if it's A, B, or C. Okay, so plot A. And then B, we got 3, -3. So am I going to go left or right?
I'm gonna go right.
To the right.
Go down.
Correct. To the right 3 and then down 3. We got B. Plot point B. And then last is C, right? We're going to go to the left and then go down. To the left, 2, and then down 3. Go ahead and connect the dots. It should look like a what?
Triangle.
A right triangle.
A right angle.
A right triangle. That's what we call these. Nope, it's a right triangle. All right, so let's read what we wrote. Horizontal and vertical lines we can count. So we can figure out the length of AC. You could do the distance formula, but why do all the extra work if you don't have to? So this vertical line, we could just count the boxes. What do we get? 6. That is correct. The horizontal line at the bottom. 1, 2, 3. I missed. 1, 2, 3, 4, 5. 5. It's totally fine. All right, and then the last one, you cannot count the boxes of a diagonal line, right, Darnell? You cannot count the boxes of a diagonal line. So what do we have to do? The distance formula. This is why it mattered that we labeled our points. Because what 2 points will I find the distance between? A and B. Just A and B. Okay? Sometimes it might be A and C or B and C. So you got to make sure you label those points to figure it out. So the length of AB, we're going to use the distance formula.
Oh, that formula.
Correct.
Yeah.
That is the distance formula. What goes in the first blank? Which letters? Which letters?
A, and C.
X. Okay, that's not what I was looking for. It's fine. I'm still writing the formula.
Oh,
It's fine. x1 minus x2 squared plus y1 minus y2 squared. Some of you still haven't learned this formula, so I would be writing it down first if it were me. All right, what is my first x?
-2.
-2. And then
No, -2.
+3. We're finding between A and B.
Oh.
A and B. I kind of like put a squiggle. I don't know.
Oh, I put A and C.
I put
Yeah.
AC too, yeah.
But we already know the length of AC, right? What's the
Yeah,
length of AC?
yeah.
It's 6. I mean, it's not wrong if you do that. You're just going to find out that it's 6 again and have done all that work for, yeah. All right, what's my first Y? 3. My second Y. -3, I plug that in. It looks positive now. All right. -2, -3. -5. -5 squared is?
25.
3 plus 3?
6.
6 squared?
36.
Correct. So now you have the square root of 61.
7.8.
Correct. You would type that in your calculator. Sorry, I'm trying to figure out where y'all are. 7.8. Do not circle that. It's not our final answer. What do we want in the end?
The distance.
The perimeter.
The perimeter. All we found was that AB was 7.8. Now we got to add all of them together. All right, so add 6, 5, and 7.8. 6 plus 5 plus 7.8. It is what?
100.
18.8, and you're going to write units. Remember, if it doesn't tell you what to write, you write units.
That's the answer.
That is the answer.
Don't we use centimeters?
If it said that each unit was a centimeter, yes. But it doesn't tell us what each of these are.
I thought you said when there's no units, you put centimeters.
But units.
You put units. So I said the opposite of what you just said.
Oh, okay. I thought you.
If it says centimeters, then yes, write centimeters. But if it doesn't say anything, you're write units.
Okay, and no squared on this one, right?
No squared, because we did not find the area inside. We found the length around. Okay? You are going to flip to the next page.
He is not for us.
We're going to do this problem tomorrow. I need you to remind me that we skipped it. Some of my classes did it. Some of them did not.
Oh, what is this?
We did it.
We did not. I need you to remind me tomorrow. Yes.
Okay.
This is a real-life example. Calm your roll. It's not that difficult. You are buying tile for your bathroom floor and baseboards for your bathroom walls. In the figure, the entire polygon represents the layout of the floor. So this is what a bathroom looks like, Darnell, right? Each unit in the coordinate plane represents 2 feet. Take your highlighter and highlight that exact sentence. Because if you skip that sentence, everything is wrong. And I'll explain how.
I don't get this sentence right now, but I'm going to get it later.
You are going to get it right now. Listen. Each unit in the coordinate plane represents 2 feet. It means this box that I highlighted in red, look, is not worth 1. It is worth 2 feet. So you have 2 feet, 4 feet, 6 feet, 8 feet, 10 feet. What is the full length of this line? 10 feet. And you can write, ignore those numbers. Cam, all I did was count each box. There's 5 boxes. Each of them are 2 feet.
I understand, but there's an 8.
Yes. But look, it starts at 3, 0 and goes to 8, 0. That means there's 5 boxes still. But each box is worth 2 feet. Everyone's okay with each box?
Yeah.
Worth 2 feet.
My fault.
Okay. A lot of people try to just count it and be like, it's 5 boxes, and at the end I'll just double it. That is not how math works. You have to make sure you put 10 feet or your answer will not be correct. This next one, all right, how many boxes up does it go?
2, 4, 6, 8.
It goes 7 boxes, which is how many feet?
14.
14. 2, 4, 6, 8, 10, 12, 14 feet. Where else is there going to be a 14?
On the other side.
On the other side, because it's the same height.
Okay.
All right, I'm going to just go around this letter T. This is 2 boxes wide, so 4 feet.
6.
Nope, just 2. This one right here.
Oh, I thought
This
you were
one.
going that way.
It's okay. I'm gonna go around like this.
Oh, okay. I thought you were going the other way.
4.
It is 4. It's okay. This one,
4.
2, 4, 6.
6.
Can everyone look at what I'm doing? What else do we know because this one's 6? The other side is also 6. All right. Then we have the very long horizontal line up there.
20.
Is 20. Because there's 10 boxes, 2 feet each.
And then the bottom left is 6.
And then the bottom left is also 6. Are we okay?
Wait, but it's 3 boxes.
Yes, 2, 4, 6.
Oh, I'm tripping.
2, 4, 6. Yeah. Okay, so now we're going to work with this. We're going to find the area of the floor first. This looks difficult because it's not a shape that we're familiar with. What shapes are we familiar with finding area? Squares,
Can I
rectangles.
just count the boxes? Inside?
No, because each box is worth 2 feet by 2 feet. Not the same with what you think.
Oh, okay.
So, how can we split this into a shape we already know? What do you think?
Put a line across the middle of the vertices.
And then what 2 shapes do we have?
We have a rectangle and
Rectangle.
a square.
Well, it's still a rectangle, but yeah. Nonetheless, same formula. The formula for finding the area is
Length times width.
length
height.
times width. Nope, just length times width. Because it's 2-dimensional, a length and a width. A height would mean it's 3-dimensional, meaning it will come off the page. All right, so what is the length and the width?
The length is 14.
The length is not 14 of this top box.
Oh.
12.
Okay, in a box, it does not matter which one you call length and width, but you can either say length width or you could say width length. It does not matter, but I don't know where we're getting some of these numbers.
6.
6 and
20.
20. Length, width. Length, width, or width and length, it does not matter.
I put
120.
I put 3 times 10, and I got 30.
Why would you? Don't tell me that. I don't know why you're doing that. I'm recording. Don't confuse things. 6 times 20. What is 6 times 20?
120.
120. So the area of the top is 120. Okay? Pause. We're not going to do anything with that number yet. We're going to go back to the bottom and find the area of that. So now that we know that the area of a rectangle is length times width, what is the length and the width of the bottom rectangle?
14 and 10.
Correct. So area equals length times width, 14 times 10, which is 140. So if the top has an area of 120, the bottom has an area of 140, how do we find the area of all of it?
Add it all together.
Add them together. 120 plus 140 makes? Yep. No. 260. Y'all made me doubt. It's 260. And it would be its area.
Square.
It is square feet. And I'll explain what that means. I'll give you a second to write it down.
260 squares.
Correct. That means if you've ever gone to a flooring store or even just Home Depot, you can find tiles that are a square foot, means it's a square that is a foot by a foot. Everyone following? So this is a rectangle. Okay, it's probably 12 inches by not 12 inches. But pretend that it was. Okay, if this was a square that was 12 inches by 12 inches, you just figured out that if you laid out 260 squares on the floor of that bathroom,
It'll cover everything.
it would cover the bathroom. That's what square feet means. Yes,
This is good to know in real life.
it is good because I remodeled 2 bathrooms.
Okay.
So
Great.
there's that.
Builder.
I have a husband too, so no, but yes.
Nice.
I picked out the tiles, guys.
Okay.
Find the perimeter. How do we find the perimeter of this bathroom?
Add all of it.
Add all the lengths. I already started highlighting up here, so I'll start up here. We got 6
Plus 20.
plus 20, and you don't have to write it all out, but I will because some of you only write and don't actually listen to what I'm saying. But 6 plus 20 plus 6 plus 4 plus 14. I'm getting there. Plus 10 plus 14 plus 6. So you do get 80, and it's just feet, because perimeter is how long the room is around the edge. So 80 feet. So this next part, I want you to relax. Just listen. Okay? The cost of a baseboard is $2 per foot. Where do baseboards go?
Mary,
Like on the floor.
They go, I have baseboards. What do they look like?
Like basically just like on
These are little carpet thingies that come up like everyone looking.
So we need a perimeter.
Correct. This is a baseboard. It lines the outside of the room. They look very nice. That is a perimeter of the room. So we know it's $2. I'm going to write down baseboard first, actually. So for these baseboards, go ahead and write that down. For the baseboards, it is $2 per foot. All right? We know how many feet we need, don't we? How many feet do we need? 80 feet. So how can I figure out if each foot is $2 and I need 80 feet? What do I do with these two numbers? I multiply them. So it's going to cost me $160 for my baseboards, which is very cheap if you ask me. All right, and then the second thing is it asks for tile. Where does tile go in this case?
On the floor.
On the floor. Yeah, it says tile for your bathroom floor. So this is area. Okay, so it's $250. I'm going to shrink this over here. Per square foot. And how many square feet do we need? 260. So again, what do we do with these two numbers? Multiply them. You what?
So that's a lot.
Yeah.
$650.
Which is actually not a lot to retile that many square feet. The size of a bedroom is probably around 100 square feet. So 260 square feet for a bathroom is actually like a decent size.
You would pay for that?
I would pay for that, 650.
Yeah.
I paid less, and I could tell you how in 2 seconds. You ready?
Let me know.
Connections?
Okay. No, but yes. No, but yes. All right, find the total cost to buy tile and baseboards for your bathroom. So how do I find the total? Add them together. So the total
It's $810.
$810. Proud you did that without a calculator.